Question number 4. Integer 0 to pi by 2 sin power 7x by sin power 7x plus cos power 7x into dx. Evaluate by using properties of integral. Now we don't have any formula to integrate directly these type of problems. A given function is sin power 7x by sin power 7x plus cos power 7x. It is impossible to integrate directly. So now let the given problem as 1. Let I equal to integral 0 to pi by 2 sin power 7x by sin power 7x plus cos power 7x dx. Let it be equation number 1. And then we have property integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. Both are maintain equal value. So we can change this 0 to a f of x dx as 0 to a f of a minus x dx, and then I equal to, can write here, we know that integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. Therefore this I will be equal to integral 0 to pi by 2, instead x substitute a minus x, that means a is pi by 2 here. So sin pi by 2 minus x power 7, sin pi by 2 minus x sin power 7 of pi by 2 minus x divided by sin power 7 of pi by 2 minus x plus cos power 7 of pi by 2 minus x into dx. Now also we don't have formula to integrate this, but we can simplify this. Sin 90 minus theta, that is cos theta. Sin 90 minus theta cos theta. Here sin 90 minus x is cos x. So this will be equal to, this integral function will be equal to integral 0 to pi by 2 I equal to integral 0 to pi by 2 sin 90 minus theta cos theta. So cos power 7x divided by this sin pi by 2 minus x also cos power 7x plus this cos 90 minus theta sin theta, so sin x sin power 7x and into dx. Now look at the first and the second one. This is equation number 2, taken equation number 2, because we don't have direct formula to integrate this function also. Here it is sin power 7x by sin power 7x plus cos power 7x. But here cos power 7x by cos power 7x by plus sin power 7x. But both are in same form. So it is this is also is not integrable directly. So we can come to a conclusion. Just look at the denominators of both. Both are equal. Sin power 7x, cos power 7x. Here also sin power 7x, cos power 7x. So the numerator here sin power 7x appeared, here cos power 7x appears. So just adding the two integral functions, we can come to a conclusion. So adding 1 and 2, 1 plus 2 implies I plus I equal to, here we have I, here also we have I plus I equal to integral 0 to pi by 2. Taken one integral value 0 to pi by 2, then adding these two functions, the denominator we have common denominator, so cos power 7x plus sin power 7x equal denominator. When adding the numerator, sin power 7x plus cos power 7x, sin power 7x plus cos power 7x. When adding the numerator, we will get sin power 7x by cos power 7x. When we add the numerator, we have sin power 7x plus cos power 7x. The denominator are equal, so we can keep the same into dx. Now which is equal to both numerator and denominator are equal, we can cancel the 2. So on the left side we have 2i equal to cancelling these two, integral 0 to pi by 2 1 into dx, integral 0 to pi by 2 1 dx. Now 2i equal to integral dx means it is x. We can apply the limit 0 to pi by 2. Substituting upper limit pi by 2 minus the lower limit 0. Now I equal to 2i equal to pi by 2. So I equal to pi by 2 divided by 2 is pi by 4. Look at here. Adding 1 and 2, we have equal denominators. We have taken one denominator cos power 7x plus sin power 7x, and adding the numerator sin power 7x into cos power 7x, sin power 7x plus cos power 7x. Now look at numerator and denominator are equal. Just to cancel these two, here 1 appeared, so 1 into dx, there 0 to pi by 2 1 into dx, integrating 1 into dx will get x. The applying upper and lower limit here pi by 2 and 0. Now substituting upper limit is pi by 2 minus the lower limit 0. So 2i equal to pi by 2. I equal to pi by 2 divided by 2 is pi by 4. That's all. This is very important problem. In example also we have this type of problem. Fifth question, exercise 2.9 here. Take a 0 to 1 log of 1 by x minus 1 into dx is given. Evaluate by using the properties of integrals. 0 to 1 log of 1 by x minus 1 into dx. Here we have limit 0 to 1. So this is in the form of integral 0 to a. 0 to a f of x dx. If integral 0 to a f of x dx, which is equal to 0 to a f of a minus x dx. We have a property that 0 to f of x dx is equal to integral 0 to f of a minus x into dx. If it is not possible to integrate directly, we can use the property. Now it is impossible to integrate directly, so just take let I equal to integral 0 to 1. Simplify this function within the bracket, log of 1 minus x by x into dx. Let it be I, and also equation number 1. Directly we couldn't go with the formula. Now by using the property, we know that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Now apply this property. I equal to integral 0 to 1 log of 1 minus of 1 minus x divided by 1 minus x into dx. Now multiply this minus inside, minus 1 plus x, that is equal to integral 0 to 1 log of 1 minus 1 plus x. When simplify this, minus 1 minus of 1 minus x, that is equal to, I am applying the numerator here, 1 minus of 1 minus x, then 1 minus 1 plus x, cancelling these two will have x. The numerator changed as x when simplified, divided by 1 minus x into dx. We have simplified. Again we don't have formula to integrate this one directly. Let it be equation number 2 here. Now adding 1 and 2, we can have 1 and 2, adding 1 and 2, we have 1 plus 2 implies I plus I 2i equal to integral 0 to 1, and adding these two functions, log of 1 minus x by x plus log of x by 1 minus x into dx. Adding the two values, 2i equal to integral 0 to 1 log of 1 minus x by x plus log of x by 1 minus x into dx. Now 2i equal to integral 0 to 1 log a plus log b equal to, we have a logarithmic formula, log a plus log b equal to log of ab. So we can multiply these two. So log of a into b, 1 minus x by x into x by 1 minus x into dx. Now look at the terms inside the bracket. Here 1 minus x, 1 minus x and x get cancelled. Remaining are 2i equal to integral 0 to 1 log 1 into dx. Log 1 value becomes 0. So 2i equal to integral 0 to 1, 0 into dx, that is equal to 0. So I equal to 0 by 2 equal to 0. Therefore integral 0 to 1 log of 1 by x minus 1 into dx equal to 0. Here question number 6, integral 0 to 1 x by 1 minus x whole power 3 by 4 into dx, and let I equal to integral 0 to 1 x by 1 minus x whole power 3 by 4 into dx. We don't have direct formula to integrate, but by property we have formula integral 0 to a, the lower limit is 0, we can use integral 0 to a, f of x dx is equal to integral 0 to a f of a minus x dx. But this is the form of 0 to a f of x dx. We don't have direct formula. We can apply the property now. Let it be equation number 1. And then we know that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So I equal to integral 0 to 1, x means a minus x, instead a we have 1, so the numerator is 1 minus x divided by the denominator 1 minus of 1 minus x whole power 3 by 4. Replace all x by a minus x in f of x. So here we have x replacing a minus x, that is 1 minus x, the numerator, and this x also replaced by 1 minus x, so 1 minus of 1 minus x whole power 3 by 4 into dx. Now simplify the denominator, 1 minus 1 plus x, so 1 minus 1 get cancelled, remaining is plus x, that is 1 minus of 1 minus x is equal to 1 minus 1 plus x, these two get cancelled, the remaining is x, so the denominator is x power 3 by 4 now, the denominator is x power 3 by 4 is equal to integral I equal to 0 to 1 1 minus x by x power 3 by 4 into dx. Now we cannot add because we have different denominators here. If we can get the answer from this integral, because these two are equal. First of all, we couldn't find the integral value directly. Then we are substituting the property. If it is possible to find the value from this f of a minus x dx, we can find the answer. After substituting the integral, after substituting the property also we couldn't find the integral value, we can merge the functions of 1 and 2, we will get the answer. Now here we need not to merge 1 and 2 because these two have different denominators. Simplifying these two functions are very difficult. So we can directly go answer with this integral only. So now this can be simplified as I equal to integral 0 to 1, bring it to the numerator, 1 minus x into x to the power minus 3 by 4 into dx. When we bring this x power 3 by 4 to the numerator, it will be x power minus 3 by 4 into x power minus 3 by 4 in the numerator. Now multiplying integral 0 to 1, x power minus 3 by 4 minus x to the power 1 into x power 1 minus 3 by 4. When the bases are equal, when multiply we can add the power. So 1 minus 3 by 4 equal to 1 by 4. So x power 1 by 4 into dx. Listen carefully here, just multiplying inside 1 into x power minus 3 by 4, x power minus 3 by 4, x into x power minus 3 by 4 means 1 minus 3 by 4 in the power. So simplify, you will get 1 by 4 dx. Now applying the x power n formula here, integral x power n dx is equal to, we are very familiar in it, integral x power n dx is equal to 0 to 1 x power n plus 1 by n plus 1. So minus 3 by 4 plus 1 by minus 3 by 4 plus 1. And then now we are integrating, we need not put integral symbol here. When integrating, x power minus 3 by 4 means x power minus 3 by 4 plus 1 by minus 3 by plus 1, minus x power 1 by 4 means x power 1 by 4 plus 1 by 1 by 4 plus 1, limit 0 to 1, limit 0 to 1. Here substituting upper and lower limit values, substituting the upper limit, 1 power minus 3 by 4 plus 1 is 1. Here also 1 power 1 by 4 plus 1 is 1. So it will be equal to 1 by minus 3 by 4 plus 1. Minus 3 by 4 plus 1 equal to minus 3 plus 4 by 4. Minus 3 plus 4 by 4 equal to 1 by 4. So 1 by 1 by 4. Then minus. The next second step is can apply. Here also 1 by, simplifying this, 1 plus 4 by 4, that is 5 by 4. Are you clear here? Substituting the upper limit for x, 1 power minus 3 by 4 plus 1 is 1. Simplifying the denominator, minus 3 plus 4 by 4 is 1 by 4. So 1 by 1 by 4. Here substituting upper limit, 1 power 1 by 4 plus 1 is 1. The denominator we have 1 by 4 plus 1, that is 1 plus 4 by 4, 5 by 4. Here simplifying this, for the lower limit, substituting lower limit here, the total integral value becomes 0. Here also substituting x, the total term becomes 0. So subtraction will get 0. The integral, when substituting lower limit, the total value becomes 0. Now simplifying this, it will be equal to 1 by 1 by 4 is 4 minus 5 by 4 means it is 4 by 5. 1 by 1 by 4 is 4 by 1 or 4. Then 1 by 5 by 4 and reciprocal it is 4 by 5. Now taking LCM, this will be equal to 20 minus 4 by 5, that is equal to 16 divided by 5. 20 minus 4 by 5 equal to 16 by 5 is the answer. Now we have completed all the problems in the exercise number 2.9, and the similar type of problems we have in examples. They are easy, they are also important. So you should complete the examples as homework. Example 2.78. Example 2.78 is the same as question number 4 in the exercise. Question number 4 we have 0 to pi by 2 sin power 7x dx by sin power 7x plus cos power 7x. This is the exercise problem 4. In example we have the same limit 0 to pi by 2, sin x in the numerator, sin x plus cos x in the denominator. Look at these two cases. This is example 2.78 and this one is exercise 4th question. Question number 4 in exercise. These two are very similar. Simple thing, the power only varies. Here we have power 1, here we have power 7. Just replacing the, eliminating the power 7 and doing the same procedure in question number 4, you can easily get the same answer of example 4 for 2.78. So you complete it as homework yourself. This is very easy, just duplicating with the question number 4, that's all. You can easily get the answer. Now we are moving to example 2.79. Example 2.79. Evaluate integral 2 to 5 root x divided by root x plus root 7 minus x into dx. Root x by root x plus root 7 minus x dx. Here we have one more formula, integral, property of integral a to b f of x dx is equal to, first of all we have learned the formula integral minus a to plus a f of x dx. If f of x is odd, the integral value becomes 0. If f of x is even, we can go with the formula 2 times integral 0 to f of x dx. The second case, we have used integral 0 to f of x dx is equal to integral 0 to f of a minus x dx. That is the second formula. Now we are applying the third formula. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. F of a plus b minus x dx. This is third case. These three type of formulas only applied in this exercise. Already I have told you. So now we are moving with the third formula, integral a to b f of x dx equal to integral a to b f of a plus b minus x into dx. Both exercise and examples we are using only these three properties to solve the problems. So here we don't have direct formula to integrate 2 to 5 root x by root x plus root 7 minus x dx. So let it be I equal to, then it is taken as equation number 1. By the property we know that integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Now by using this property, I equal to integral 2 to 5 within same limit. Instead x, we are substituting a plus b minus x. A is lower limit, b is upper limit. Sum of the two minus x. That means lower limit 2, upper limit 5. Sum of 2 is 7 minus x. So root of 7 minus x divided by root of 7 minus x plus root of 7 minus of, for x we are substituting 7 minus x into dx. Are you clear this? Listen carefully here. Instead x is replaced by a plus b minus x. That is a and b are lower and upper limit. So lower and upper limit 2, 5. Adding these two values a plus b, this 2 plus 5 is 7. So minus x. So replace x by 7 minus x in a f of x. So this is f of x. All the x are replaced by 7 minus x. Because 2 plus 5 is 7. A plus b is 2 plus 5. 7 minus x. So x is 7 minus x. Here for x we have replaced 7 minus x. And here also for x we have replaced 7 minus x. 7 minus of 7 minus x dx. Now I equal to integral 2 to 5 root of 7 minus x divided by root of 7 minus x plus root of, now multiplying minus inside, 7 minus 7 plus x into dx. Now this I will be equal to integral 2 to 5 root of 7 minus x divided by root of 7 minus x plus root of x. 7 minus 7 cancel, remaining is x, root x into dx. And here also this is in the form, same form, just a difference, a little difference. So we couldn't directly integrate. This is taken as 2. Now we can merge this. In the last problem we are not merging directly, we can we got the answer from the second integral, but here it is impossible because this is also to solve this one we don't have direct formula. Now we can merge this because we have equal denominators. we can merge when we'll get the numerator as the denominator value. Look at here, root x plus root 7 minus x. Here also root x plus root 7 minus x. Both the denominator are equal. The numerator root of 7 minus x and the root x. Adding these two will get the denominator. We can easily simplify that. So adding 1 and 2, 1 plus 2 implies 2i equal to I plus I, 2i equal to integral 2 to 5. Adding, when we add, take the denominator root x plus root 7 minus x. Here the numerator is root x and here the numerator is root of 7 minus x. So adding these two functions, denominator are equal, we have taken one equal denominator, and root x plus root 7 minus x in the numerator into dx. Now look at the numerator and denominator. Here both are equal, so we can cancel the numerator and denominator, which implies 2i equal to integral 2 to 5 1 into dx, which implies 2i equal to integral x 1 into dx integral dx is x, limit 2 to 5. So 2i equal to upper limit minus lower limit 5 minus 2. Substituting upper limit 5 minus the lower limit 2. Now it is equal to 3. So 2i equal to 3, which implies I equal to 3 by 2. So the integral value of I is equal to 3 by 2.